Okay, good morning, guys. Um, so we will be having our classes on asynchronous class. So I guess we're already on LP3 and LP4. Basically, during quizzes and exams, long quizzes and exams, I usually just go to the concepts for simplicity. If ever we'll be doing learning outcomes in the exams, so it would be minimal. I think we are only allowed at about 40%. So 10% for understanding, um, no, analysis and application, and then another 10%, 30% for an application and analysis, and another 10% for your evaluation. So I think our learning outcomes goes to those kinds of level of um, level of learning. So anyway, this one should go to your, I mean, should be on the level of understanding. So I think I've already talked about functional group. So they are just the table. So again, you need not to memorize, but at least mm, you can, you should know how, when to use the functional groupings. I mean the table for functional groups. So I open the book from the library. So this I'm talking about this table. So we've already discussed about that. So you can use the table again. So just photocopy it and you can bring it during quizzes and exams. Okay, because I really don't want you to memorize. And then next is alkane and aliphatic. Alkane is pertaining to the first organic compound functional groupings. So meaning they are single bonded. So as you can remember, that is you have a carbon at sp3, sp3 hybridization. So it has four divisions of your spaces. So that's what alkanes are. So then you have the term aliphatic. So an aliphatic term is just to contrast it with aromatic. Okay. So aromatic is pertaining to those which has benzene ring, while aliphatic pertaining to those which do not have benzene rings. Okay, and then or we call them open chains organic compounds. And then you have the term hydrocarbon. So hydrocarbon, as the name implies, it is a compound which is usually only made of carbon and hydrogen as the element. Okay, so that's what it stands for. Usually hydrocarbons are combustible because it readily reacts with oxygen from the air. Some even reacts without the presence of flame. It's another topic, but you just only have to be familiarized that hydrocarbons react with oxygen in a combustion process. So hydrocarbon meaning that term implies a compound with carbon and hydrogen. Usually alkanes, alkenes, alkynes, as some of them or most of the alkanes are hydrocarbons, meaning not most but many of the substances that we use in the alkanes are hydrocarbons, meaning it only contains hydrogens and carbons. And then you have the term saturated. Again, it's a term. It's not like the term we use in general chemistry, wherein saturated means a concentration. No, saturated here it talks about the single bond and double bond, or triple bond. So saturated meaning they are synonymous to being an alkane actually. Saturated because when you talk about carbon to carbon single bond, we usually have that term saturated if it doesn't contain a double bond or a triple bond. So you can usually see those terms, or encounter those terms during let's say polymerization, wherein a polymer is highly dependent on double bonds and triple bonds. So usually the term there is unsaturated. They are usually chemists and polymer chemist usually looks for compounds which has an unsaturated carbon, meaning it has double bonds and triple bonds. And then you have the branch chain alkanes. If you have an alkane which is a straight chain, so it is a straight chain, meaning the carbon is connected from left to right. But if you have carbons which are secondary and tertiary carbons, as the discussion from the last discussions that we have, if you have tertiary and secondary carbons, wherein you have carbons or you have organic compounds stemming out from the carbon. So for a primary carbon, again, primary carbon um, has 1 R and 3 hydrogens with it, while secondary carbons are carbon which has 2 hydrogens with it, while it has an R, a dual R. So as you can see, those R's are also carbon. So so it becomes already a branch chain because you have already a branching chain of carbon. Okay, usually, especially for the tertiary type of carbon, you can encounter the branch chain alkane. Okay, and then we have the constitutional isomers. I think I already gave you an example with it, so I'm just following these definitions of terms. Constitutional isomers are those isomers which has the same which has different constitution. Okay, I think we also have the term functional isomers. So constitutional isomers, they have the same atoms and elements, but they have different placement of those carbons and hydrogens. So we call it constitutional isomers. And then that isomers, again, there are general of that. That's the general term for isomers, which were in there. They are many in organic chemistry. So isomers from the word iso and mer. Mer is an entity or a unit, and then iso means the same. So when you say isomer, so that would be the same entity, or it contains the same elements, but of course it is a different compound. So it's a different compound. It depends because there are a lot of isomers. So as I've said a while back ago, there is even a constitutional isomer. There's a functional isomer, there's a stereoisomer, there's an enantiomer, there's a lot of isomers actually. There's an L and D isomers, and so on and so forth. So isomers is the general encapsulation of those types of organic compounds wherein they are different but they contain the same elements and number of elements. Okay, you have straight chain alkane. So in contrast with branch chain alkane. So an alkyl group is an alkane with one hydrogen without one hydrogen. Why? Because that without hydrogen part, that bond there is ready for a bonding. So actually we just call it branch in our parent chain. So we call it an alkyl group. Okay? So an R group is might be also an alkyl group, but R group is a general term for a substituent, which is an R which represents every functional group. As long as it is an organic compound listed in the functional group, it is called an R group. Usually, this discussion is important in the discussion. Let's say um, amino acids. Amino acids can be identified with their functional groups because with their R group, because the one side of it contains the amino group, which wherein they all have the same amino group. They all have the same acid group. So an amino acid is an amine and an acid, which is important to them. They are grouped because they both have the same amine group and they both have the same acidic group, which is a carboxylic acid. So they are identified now with the R group. So the R group differs from one another. So it's really important to know that R group are just a representation of any organic compound that are okay, and it will also behave as a substituent, just like the alkyl group. So an alkyl group is also actually an R group. Okay, but an alcohol an alcohol substituent can also be called an R group. Okay? And then we have substituent. Again, that is a general term for as long as it is not highlighted in the mother chain, as we have discussed that in naming or nomenclature, we need to identify the parent chain. So if you have already identified the parent chain, other groups that attach to that parent chain is, we call them substituent. Okay? Branch. Okay? So I think it would be too long already, so we'll cut this video from